Lecture 15 Introduction to Computational Thinking. Hi there! Today we're diving into the world of computational thinking, a cool way to solve problems like a pro. After learning this lecture, students will be able to define, explain, and implement computational thinking in the problem-solving process. Explain and use the key skills for computational thinking. Decompose large problems into multiple small ones. Understand the basics of pattern recognition, abstraction, and algorithm designing. Let's go! What is computational thinking? Computational thinking is like putting on your detective hat. When you face a problem, first you figure out where the problem comes from. Then you think of smart, logical ways to solve it. Imagine cracking a code or solving a puzzle. Sounds fun, right? This skill helps us make tough problems simpler, step by step. The 4 big questions. When solving a problem, always ask yourself these questions. Where? Where does this problem happen? Who? Who is affected? How? How can we solve it? When? When does it occur? Keep asking why, which, what, and who. These are your super tools for understanding problems. Key skills of computational thinking. Computational thinking has 4 important superpowers. Problem decomposition. This means breaking a big problem into smaller, manageable pieces. Pattern recognition. Spotting similarities in different problems to solve them faster. Abstraction. Ignoring extra details to focus on what really matters. Algorithm design. Making a step-by-step plan that even a computer can follow. Why are these skills important? Imagine a table with 4 legs. If one leg is wobbly, the table can fall. Computational thinking works the same way. All 4 skills are super important to solve problems perfectly, whether in life or on a computer. Focus on problem decomposition. Let's zoom in on problem decomposition. It's like cutting a big cake into smaller slices. It makes solving problems quick and easy. Once you break the problem into smaller parts, they become less scary and easier to tackle. Think of a big project split into tiny tasks. It's so much more doable. Examples of problem decomposition. Let's see how we can solve problems by breaking them into smaller parts. Examples of problem decomposition. Let's see how we can solve problems by breaking them into smaller parts. Example 1. Cleaning your room. Imagine your room is super messy. Yikes! To clean it up, you can split the task into smaller steps. Arrange your toys. Organize your wardrobe. clean the tables, set your bed, clean the floor. Step by step, you'll go from chaos to a tidy and beautiful room. Doesn't that feel great? Example 2. Hosting a birthday party. Throwing a birthday party can be a big job, but let's break it into smaller tasks. Decide the menu. Ask for help with the cooking. Assign tasks like decorations or bringing supplies. Plan when everything will happen. By tackling each small task, you'll have a fabulous party ready in no time. What is pattern recognition? Next up is pattern recognition. This is when you find similarities or patterns in problems to solve them faster. For example, have you ever played with a Rubik's Cube? You use patterns to solve it. Or noticed how you eat in a pattern? Bite, chew, swallow. That's recognizing patterns too. The more patterns you find, the easier problem solving becomes. It's like spotting shortcuts. Fun examples of pattern recognition. Have you ever solved patterns in math class? That's pattern recognition. Using Lego blocks to build something cool by repeating shapes is another example. Even finding even or odd numbers in a list is using patterns. How fun is that? Class activity. Play with patterns. Let's try some fun activities. Solve a Rubik's Cube by following patterns. Build something exciting using red and green Lego pieces. Find even and odd numbers in a set. Patterns are everywhere. Start spotting them. What is abstraction? Now, let's learn about abstraction. It's all about ignoring extra details and focusing only on what's important. Imagine playing an escape room game. You focus on the clues that matter and ignore the distractions to solve the puzzle. Abstraction helps us concentrate on the main problem. Example of abstraction. In an escape room, there might be lots of unnecessary props. The best solvers ignore those and focus on clues that help them escape quickly. By focusing only on what's needed, you can save time and effort. Thank you for learning with me today.